Hi, I'm Graham Steele, CEO and founder of CryptoSense, and today I'm going to talk about the Codecov attack and what it tells us about cryptography management. So, what was the Codecov attack? So, Codecov is a piece of software that you can use to measure and manage the coverage of your tests on your code. So, it's a tool that's used by developers or as part of the development process to help us to decide which new bits of code to check in, if they've done enough testing, how to keep a good visibility on the way we're doing testing and so on. So it's a sort of a code quality tool. And it's very widely used, and it comes with nice integrations that you can use to build it into common tools like GitHub and Circle CI, so that you can use it directly in your CI chain as you're building your software. So sometime between January and April this year, 2021, attackers managed to get access to the code that is inside Codecov. So the way they did that was there was a credential inside a Docker image that was being deployed, a hard-coded credential that the attackers saw. They used that credential to access just a little bit of code inside Codecov, specifically an upload script, and they injected a line of their own code into that upload script. So this upload script was used by customers of Codecov to send their testing results to Codecov, or it's also used inside the CI integrations that Codecov supplies inside GitHub Actions and inside Circle CI to do that upload. And the interesting bit of code that the attackers injected was to run a command to suck out from inside wherever it's running, that script, all of the environment variables, and send those environment variables to the attacker's IP address where they could suck them in and then use them. So why were the attackers interested in environment variables, particularly environment variables that are coming from where this upload script is going to be run, which is typically going to be inside your CI environment? So we often use environment variables these days to store credentials and secret keys. Why do we do that? It's not necessarily what they were intended for when they were first created. Well, the reason we do that is that we don't want to put credentials and keys, for example, directly inside application code because of all the risks associated with that and the difficulty of changing it. Instead, we want to make them separate and keep them hidden away from developers, so we put them in these environment variables. But these environment variables in a CI environment can actually be very sensitive credentials. They can get hold of really sensitive data. So for example, your CI environment will typically always have accessible as an environment variable a credential for accessing your code, so accessing your GitHub, for example, to pull down code or to send up issues. And so if the attackers were able to put this malicious bash upload script in your CI environment, they're also going to get the credential for your code. Well, that's already not so good, so that allows them to carry on this chain of supply chain attacks by injecting code maybe into your repository. Plus, people, when they're making these CI environments, what you're trying to do here is replicate, in a sense, your production environment, so build enough infrastructure that you need to really run your tests to check that these new changes you made to your code are really going to work how you want. And some people are very, very scrupulous about separating off their production infrastructure from their test infrastructure. So the CI environment wouldn't have any access to the real production database, for example. But that's not the case in every CI environment. Sometimes people have the same service credentials accessing, for example, a cloud service to get access to the production side and to get access to the test side. And so in that case, this is obviously really nice, juicy credential for an attacker to get hold of because it's going to be a service credential for your production systems. There's even other things you might have in there. So you might have in your CI environments your signing keys to sign a new update. So you've built some new code, and now, following good practice, you're going to sign that update before it goes to your customers so the customers can verify that the update really came from you. But in order to do that, you might put that signing key in your CI environment, and that might be accessible to somebody who'd made this kind of attack. And indeed, a few weeks after the attack was announced, a company called HashiCorp announced that, in fact, their GPG key, so their signing key, their code signing key, had been compromised as a result of this attack. So that's the company that makes really widely used tools like Terraform and Vault and so on. So Terraform is another tool that's used for more supplying in the supply chain. So this attack is really sort of chaining all kinds of interesting credentials from the point of view of the attacker through other people's supply chains and giving them lots of interesting attack routes. So what should you do if you've been affected by this kind of attack and your environment variables from your CI environment are maybe out there in the wild? So clearly you're going to have a look at all of those credentials that you put in that environment, and you're going to have to roll them or change them, get new ones. So that's fine, you could go ahead and do that. But what people affected by the attack typically found was this is a lot more difficult than they imagined it was going to be, because it's very easy to change the credential in the environment variable, that's no problem, but you've got to change the credential that corresponds to that. So if I change a database credential, I've got to actually change the database on the credential on the database backend system so that this credential will really work to access it. Well, that's fine, but if I change that credential on my backend database, I've got to find out where else was that credential being used, anywhere else in my systems, by anything, any maintenance scripts or whatever it is, because if I've changed that credential now, they're not going to work anymore. And I'm going to have to go through and do that with every single credential that was in any environment variable of any application, anywhere in all of my CI. And any one of those application credentials, those environment variables that could chain on. So for example, if there was an API key in there which allowed the attackers to possibly get access to my GitHub repository, for example, well then I better go through my entire GitHub repository and make sure there's no credentials in there that might allow them to chain further forward into something else. And I'm going to have to roll all of those credentials as well. So this was a mammoth recovery task for a lot of organizations, and it's another great illustration of the advantages of keeping a up-to-date automated inventory of all your cryptographic keys and credentials all the time. So even though you know you are in a good state, if something goes wrong, you could immediately say, okay, well, I need to change this key, and I know this key is being used here, here, and here by these other applications. So they're the other places that I need to roll the credential to make sure that nothing goes wrong. So it's another great illustration of the benefits that you get from keeping a tight, automated inventory of your cryptography that's up to date all the time. So we have another video about that if you want to find out more about that. Otherwise, don't forget to subscribe to the channel to stay up to date with all the news around cryptography, cryptographic attacks, and so on. And I'll see you here again soon for another video.